This is our third session. It's just me tonight. Siobhan will be here next week. And we've got an interesting lineup for you, continuing our exploration of Java, but we're hoping to leave the core language behind now and start to take you into the world of some of the Java libraries. And after this week, we'll be pressing on with much of our core curriculum in agile techniques in general, starting with testing next week. Still need to cover some material though of the fundamentals, and this week our topic is inheritance and collections. With 4 talks in here to go through with you this evening. General introduction to inheritance and a specific type of inheritance called implementation inheritance. And then another variant of a similar concept called interface inheritance. These are 2 distinct variants of the same concept in Java. One of those is now considered to be flawed, and the other is considered to be the most appropriate type of deploying this concept in our software. So it's interface inheritance is where the sentiment is shifted dramatically. Once you've concluded that, we'll have the toolkit to look at collections. This is a very fundamental and important library that's part of the core JDK. It's quite a complex and large, sophisticated library, an award-winning library, in fact, in its time, perhaps showing a little bit of its age now, but still very much widely used. We introduce collections and review the primary features, and then we'll go through some more advanced topics in collections. It's too big a topic really for us to spend too much time on. We've one lab this week, as before, continuing with the little application you're building. This one is moving on a little bit further, and remember from our discussion last week, this is the foundation for your assignment. So perhaps at the end of this lab you'll be able to have a good go at the core features we've asked you to have a look at. There will be more to come in the labs for your assignment, but the substantial range of at least core features will be implemented by this particular week's lab. Okay, the chat room is here as usual. We are blessed with 3 chat rooms, not when 1 would do. So we have this chat room here, which is private. I may have emailed you asking you for your ID to invite you into that room. If you're not in the room, you could drop the email into the chat room on Adobe Connect here. And what I'm looking for is your Gitter ID, which might be your GitHub ID if you link your accounts. We can do that during the break. I'll be taking breaks as we go along. I realize that some of you may not have access to it yet, so I'll keep monitoring the Adobe Connect chat room as well currently. Okay, so we're going to start then with our introduction to inheritance. It's an interesting topic because of the way it has changed over the years from its original concept to now what's considered better or maybe less good practice. And we'll try and touch on that today, but we'll be doing more of that a bit later on as well. You'll recall we had quite a rush last week to get through the range of fundamentals of the language itself. That is, in last week's sessions, we were looking at overviewing the language, classes, control statements. And of course, we also spent some time exploring the assignment we've asked you to have a look at. This week's topic is here. We're looking at inheritance for the first few talks. And once that's out of the way, we can proceed then to look at collections. 2 fundamental parts of the Java ecosystem. Now, the other topics here we will be covering, but not today. You'll be glad to hear. Exceptions is a topic for a future class. Again, the way we use exceptions has changed over the years, so we'll be interested in looking there at how exceptions were originally designed and now how certain modes of using exceptions are considered poor practice. And we've already started a little bit on streams, but we'll do it in a bit more detail. That'll also be the next week or 2. You're using streams in the in the labs at the moment without any real explanation. I think we're going to fix that in the next few sessions. Okay, inheritance then itself. Let's look at what it is, and then we'll focus our first talk on this specific type of inheritance called implementation inheritance. We look at the syntax in Java, look at some of the quirks, look at how it impacts on constructors, and then we'll also introduce the concept of abstract classes. There is another kind of inheritance that I'll be mentioning called interface inheritance. Both share general concepts, but their realization is quite different, and we need to be able to pull those apart in the next hour or so. Implementation inheritance is taught to promote reuse. Commonalities are stored in the base class, and we're sharing those commonalities across all the subclasses, and I'll explain those concepts in a moment. There is a fairly strong question mark now around the first of these. That is, does it really promote reuse in an effective mode or not? We will be discussing whether that really worked out or not in a later class. Interface inheritance is shifting our concept from classes to types, and we talk about whether a given class supports or implements a type rather than more general inheritance concepts. It's a subtle change of terminology and ultimately quite a significant change in how it's realized. Leave that for the moment, and let's just look at the concept. The concept is more generally called generalization and specialization. It's a core relationship that is perhaps part of the problem domain we're tackling, or visible in some analysis of the problem domain. And here we're seeing a policy, and then maybe a home policy, auto policy, and life policy. I think talking to some life people about policies is a bit risky, but we'll press on. The idea here is that at the base class, that is up at the higher level, there is a generalization. And this generalization represents an idealized or maybe abstract policy. And then we choose to introduce multiple realizations, and these are called specializations of that policy, as other classes in our implementation. And those classes inherit, or we could say share, aspects of the base class. Syntax is via the use of the word extends, which we append to the class declaration. And once we introduce that, we have to name the base class, and then we're introducing that relationship. We noted last week that Java is one of those languages that has a cosmic superclass we call it object. So if you introduce a class without any base class, it does already have one. It has object. So there's no escaping the inheritance relationship in the Java language, which is why we need to be very comfortable with how it works. When we introduce objects or variables of a given class, we often declare those variables to be associated with the base class rather than the derived class. For instance, in this line here, we're declaring a policy object to be of type policy, policy being our base class here. But we're creating an object that is an instance of the derived class. We're saying I want a life policy. That life policy is this class over here. And we're happy enough to do that. That is to generally tend to prefer our types associated with base classes rather than derived classes. We'll discuss why that is a little bit later on. Now, what do you get in inheritance? We can think of inheritance as a special type of relationship between two classes. In fact, it's a very closely coupled relationship. We're getting everything. We're getting all the fields and all the methods. The only thing we're not getting is the constructor, which we'll talk about in a second. So if the base class has a range of fields, those fields are now in the derived class objects. Similarly, any methods now become part of our derived class. Remember, we're introducing a new class. We bring in auto policy, life policy, and they will have all the fields we are declaring in the base class. So both methods and fields are inherited. and the inheritance hierarchies can be multiple levels deep. We're only showing one level here, but there is effectively no limit to how deep this inheritance hierarchy may go. Now, once we introduce the relationship, we do then have to consider things like what method is invoked, particularly if methods are shared between the base class and the derived class. So here is our policy again. We have a premium get premium method, and we're attempting to invoke that method inside the derived class. This triggers what's called method lookup, and in our derived class we do not have our own implementation of get premium. So get premium is going to have to be triggered from the base class. This means that the lookup takes place on the object itself, and we revert to a method one level up in the hierarchy when we wish to perform the get premium operation. This is possibly the source of some of the challenges to do with inheritance, as we'll see later on. We're not quite sure which method is being invoked, and we may end up going up and down hierarchies attempting to find the method that is most appropriate. Now, it's not obvious in this simple example here, but this proves to be a bit of a flaw in the design of inheritance, the flaw really being complexity. Here's another example. This time we've got a class called home policy extending policy, and we're invoking a print method. Now we're invoking that print method from within another version of the print in the derived class. So we're looking here at a print method. Its job is to print out the policy details, and we note we've got this funny syntax here, which is super.print. So super is a keyword only relevant when we're in an inheritance hierarchy, and in this case it triggers an invocation of a base class version of print rather than the current print. If we were to leave out that super, we'd be in trouble, because we'd be invoking print, and that would be a recursive call on print, which means our program would crash with a stack violation almost immediately. We can ask a class, what is our type? We rarely do this, but in certain circumstances we may be either confused or we may have a design that is overcomplicated, and that requires us to find out, well, what type are we at this point? This would occur when we have acquired access to an object without it being typed to its derived class. So it was an object class we were interacting with. We won't have cause to use this or really be seeing it again, but it's useful occasionally when you're exploring the concepts initially to try out these features, just to get a handle on the nature of typing in Java. You can invoke get class on an object, and then you can even ask it for its name, which will be the class name. Let's go back to our print example again. Here we're in the derived class print. We are invoking the print method. We're using the word super. So the super means we're going straight up here and we're invoking the print in the base class. That print method is printing out its own fields. We notice it's also taking advantage of the get class method to just flag what we think is the class name at this point. And when that's finished, we'll proceed with the derived class implementation, and ultimately the output will be a combined output of the base and the derived class print. Again, that looks a little bit complicated, and if you're finding it challenging, if you're new to Java, well, it's not surprising you're finding it complicated, because it is. And because it is complicated, we are shying away from this pattern in general. The print method is an example of overriding in Java. And when we say we're overriding, it means we're matching the base class function precisely. And then we are implementing that base class method with a revised implementation. We don't have to invoke the base class method in our derived class, so this is not required in any sense. It's just optimal in this particular environment here. Okay, constructors then are also implicated in how we implement inheritance correctly. If you've got our base class policy and a derived class home policy, and in this instance now we are initializing the base class with a range of important fields, then our derived class must provision those if we wish to have that constructor invoked. It's the same syntax we just looked at with print. That is, we have a super keyword, and that super keyword triggers the invocation of the base class constructor in this instance. We're not naming the constructor, we're just automatically selecting it based on its parameters. This is essential. If we don't match the base class constructor, we may get an error. If there is a zero argument constructor in the base class, then it works automatically and we don't need super. That's a subtle source of bugs there in its own right. Abstract classes. So we've looked at the basic concept, the extends keyword, the use of super. Super used both for overriding methods and for ensuring we can acquire the base class constructor invocation. Last topic in this section is abstract classes. And we have a new keyword in Java, the abstract keyword. We can denote a class to be abstract. This is a design decision we may take, perhaps based on the problem we're solving. Perhaps we're capturing a concept in our class that we never want to be concrete, but it does lay down the shape of something that's important, and perhaps that will share a behavior and a structure across multiple classes. So a generalized policy could be marked abstract. We may never, in fact, we may insist upon never implementing a policy. And then we're free in our derived classes to implement the policy completely. And the abstract keyword marks that we've made this decision. In addition to marking a class abstract, we also can mark a method abstract. And this gives us even more detailed design information. We're saying that this class is not only there and perhaps has certain fields, it has specific methods which must be implemented for a concrete class to become viable. Note here that I have a semicolon there. That's important. There's no body or implementation to this class. This class has no meaning in policy except that it is defined. That is, its signature is established. So it's an abstract method, and then that abstract method must be implemented in the derived classes. If those derived classes do not implement a method, then our Java environment will object. It won't object unless we attempt to create an object of the derived class. So we may choose to not implement calculate full premium, but in that case, we're still living with an abstract class at that point, and a further derivation step will be needed to make it concrete. Okay, that's a basic roundup of implementation inheritance. It's the extends keyword. There's overriding. There's the use of super to trigger base class methods or constructors. And then there's the added complexity of abstraction being imposed on the classes, whereby we can mark individual elements to be abstract, or we can mark the entire class as abstract, or both, as it turns out. I should mention that abstract classes may also complete function implementations, methods, and may also have their own fields. Now, one last topic, multiple inheritance. We can visualize B and C derived from A, so it could be home policy and life policy derived from policy. But could we envisage a D? Could it be a special hybrid policy of some kind, for instance, that was both a home and a motor, for instance? Well, that's not supported in Java, and I'd like to review very briefly why that's not the case. So a thought experiment, suppose we have a brace class, maybe we mark it as abstract, and we have a method do, and then we've got an implementation, implementing do, and another implementation, that is another class, also implementing the same method. So we're implementing the abstract base class in two concrete implementations. This is okay, that's perfectly fine. If we had multiple inheritance, we could be tempted to try and write a syntax something like this here. That is, there are two base classes specified in sequence. Syntactically, that might make sense. We might even imagine that it could be realized in some successful manner. And it could, but it leads to a breakdown in our understanding of overriding here. And because we've got a do method implemented in the base class, in the two derived classes, and now in the multiply derived class, then we have a conflict around which version of the do method should be selected. So when we invoke do on a diamond effect object, there's an ambiguity here. Now, addressing that ambiguity, we could envisage a syntax to resolve it. Java decided not to bring in such syntax, so multiple inheritance is not possible. It should be noted, however, that it is possible in a whole range of other languages, including the direct ancestor of Java called C++, and it uses a special mechanism called virtual base classes for just this purpose. That's it then for this topic for the moment. We've got our basic introduction. We will be returning to this type of inheritance a little bit later on in the module, but we'll take a short break now, and then when we resume, we will continue our discussion of inheritance, this time a different style. Let's take 5 minutes, and I'll be monitoring the chat room in that time if anybody has any questions, or you'll have a few minutes to take a little bit of walk around if you like as well. Okay, see you in a second.